Okay, a big scary question here with probabilities involved. Okay, there are some giveaways. Okay, we mentioned independence is being mentioned. There are also the fact that there are 50 customers. Okay, and we are counting the number who will not turn up. We want the probability that 2 or more will not come up, and we know the probability of each customer not turning up is this. So we've got a number of trials, and we've got a probability of something happening on each trial, and we're counting the number of successes in n independent trials. So that's the kind of thinking you need to do. The other thing is that we've got question 7, and there hasn't yet been a question on the binomial distribution. So the first thing you have to do is spot that this is a binomial. So x is twiddles b something something. We have an n value, we have a p value, and we're going to be using your binomial distribution modes on your calculator to work out individual things. Okay, these are 2 or more not turning up and 3 or more not turning up. So in each case you're listing the outcomes. There are 50 customers, so it could be anything from 0 to 50, but you're going to have lots of dots in this. For the first one, if you just do that diagram, and then you're going to indicate on this list of outcomes, this diagram of outcomes, 2 or more not turning up. So it could be 2 not turning up, it could be 3 not turning up, but it can't be 0 or 1 not turning up. So we need to think, how would we calculate the probability of this combination of outcomes, which we can't do directly, but we can think about the unboxed ones, and so we can do a 1 minus some probability, and you can use your calculator to get this probability, and that should tell you the answer. And then for 3 or more not turning up, it's a similar diagram, but you draw the diagram and you do the correct thing and you should get the right answer. So that should be the first 4 marks. And now we've now got the theme of the question. So now, okay, we've got a different number of customers. Okay, but now we know the probability they won't turn up is something different, but we've got a new n and a new p. But once again, we want the probability of different things happening. So, once again, you do the list of outcomes, okay, you put a box around the ones you want, okay, and your calculator again will supply you with the answers if you use the diagram correctly. And then finally, we've now got a number of seats, and we've got another number of seats, and 15 or 14 or fewer customers who've booked seats on the minibus turn up, they will be allocated a seat on the minibus. If all 15 have booked seats on the minibus turn up, 1 will be allocated a seat on the coach. This will leave only 47 seats available for the 50 customers who've booked seats on the coach. Okay, you might have to read this paragraph through a couple of times till you're really sure you know what that means. But we want to find the probability there will be seats available on the coach for all of those who turn up having booked such seats. Alright, so it's a 2-stage thing. I think it's a tree diagram, isn't it? Either, okay, there are 48 seats on the coach, which is all of them available, or there are only 47 seats because everyone turned up for the minibus and someone had to be transferred. So the first phase of your tree diagram is whether really there are 48 spare seats, or 48 seats or 47 seats on the coach, and that will the probabilities there will be connected with whether everyone turned up for the minibus. So if everyone turned up for the minibus, we're going to have 48 seats on the coach, but if some people didn't turn up, we'll only have 47. So the probabilities for the first stage of your tree you calculated in part B. And then if there are 48 seats, then the probability that will be okay. We want to find the probability that everyone will be able to get a seat. So we'll be okay, as long as 48 people, only 48 people or fewer than 48 people are there. In other words, of the 50 people that booked seats on the coach, so there were 50 seats, customers booking seats, okay. If 2 or more don't turn up, we'll be okay because we've got 40 seats available. So the probability we need here for being okay, all right, will be the probability of 2 or more not turning up, and we can easily find the probability of us not being okay here. And similarly for 47 seats available. Either we're okay or we're not okay, and the probability you need here to get you started actually has been sorted out for you again in part A. So parts A and B in this question, okay, where we actually had to use a binomial distribution, but once we've got all of those answers, this part C is just about combining them and thinking about a tree diagram arising from that using the probabilities you've calculated. So we want the overall probability of being okay, which will be the sum of 2 routes through the tree. I hope that helps.